Today, I'd like to introduce Dr. Harishchandra Sabhajeet Nishad. He is a doctorate in, he has done his doctorate from nanosciences and nanotechnology from University of Mumbai in 2024 and was awarded a doctorate in 2024. And he has been in the research, he has studied his MSc from the same university college in nanosciences and nanotechnology.
Okay, so thank you again very much to giving me a beautiful introduction about mine. So as sir introduced me that myself Dr. Harishchandra Nishad, and right now I'm a research fellow at Nanoscience Nanotechnology, and next month I'm moving to Korea for my further study. So okay, today I have decided to give talk on title from the electronic e-waste to energy and developing supercapacitor for sustainable energy storage. So basically this talk be divided in two parts. First will be based on the supercapacitor. There is a hardcore technical session like related to nanoscience, nanotechnology, how nanoscience, nanotechnology can be used in energy storage devices like supercapacitor. And second will be based on the electronic waste. So let us move for, this is my profile of my research. Basically, I'm working on aqueous zinc and battery as well as supercapacitor. So we are looking to alternate of the lithium and battery. So we are developing anode and cathode material for zinc and battery by using several nanomaterials along with the electrochemical supercapacitor for fast charging discharging process. So in my today talk, I will going to discuss related to introduction, then supercapacitor, electronic waste, that is called in short called e-waste, then solar lamp from the e-waste, how we can utilize this electronic waste as a useful product, then solar based smart alarm. Then we'll do the summary of the entire discussion. So this is my introduction. So here we can see that there is a left hand side is production of electricity by various source like wind energy, solar energy, nuclear energy, and various source of energy. And right side there is a consumption of that electricity, or we can say energy, and right hand side. So if take example of the wind energy and solar energy, they are discontinuous generation. So every time we can't generate electricity. So between production and consumption, there is a gap between production and consumption. So that gap can be fulfilled with electrochemical supercapacitor and battery also. So, and it is not about the renewable energy like discontinuous generation. If we are using like portable electronic gadget, so we need also required to store energy. So that at that time we need also electrochemical energy storage devices. So battery and supercapacitor are the most promising technology. So right now in this today's presentation, I'm going to discuss about the supercapacitor. What is the detail about the supercapacitor? So this is the basic schematic diagram of the supercapacitor, where consists of one anode, then cathode, then it consists of electrolyte here and separator. This is separator separated. These two electrodes are separated by this separator, and in that there is a electrolytes are there, which is a combination of anion cations, and also there are solvents are there, which electrolytes are dissolved. So this is the schematic diagram of that supercapacitor, and now we are going to understand so how engineering or tuning that anode material and cathode material we can enhance the performance of the supercapacitor. Like we can increase the capacity, we can increase the energy density, we can increase the power density by using a certain nanomaterial. So now we are going to discuss about the what is nanomaterial. Nanoparticles are there. So based on their dimensionally, they are characterized mostly in four types. First is zero dimension nanomaterial. Example quantum dots, fluorines, some gold nanoparticles. They are come under the zero dimension nanomaterial. Then 1D nanomaterial, which comes like nanotube, nanowire, nanorods are there. They are coming under the one dimension nanomaterials. And 2D nanomaterials come like thin film, nanoplates, layered structure. Example of carbon coated nanoplate, graphite sheet, layered structure like MXZ, layered hydroxides, MOS2, WS2. These are coming under the 2D category nanomaterial. Then we have the 3D nanomaterial like liposomes, polycrystalline, dendrimer, and many others are they come under the 3D nanomaterials. So among these two nanomaterials, 2D nanomaterials are most promising and highlighting for the energy storage application like battery and supercapacitor. because two-dimensional nanomaterial have a 2D quantum confinement and larger surface area as compared to other material, and so on, like layered properties. So ion can integrate easily inside the material and perform the redox reaction. So what is electronic waste? What is e-waste, or we can say in short form? So electronic waste or e-waste refer to discarded electrical or electronic devices. These include like old mobile computer, televisions, smartphones, tablets, and other gadgets that are no longer in use or have reached the end of their life. That's come under the electronic waste. So now we need to also focus and make aware people about the electronic waste, because as science and technology we are adapting, same times we are also generating or creating electronic waste in our society, in our mother earth planet. So we need to also focus. So later, source of electronic waste, so where the major electronic waste are produced. So mostly, let's start with our home. The most of electronic waste we are producing from our home, like personal computers, televisions, radio, cell phones, washing machines, microwaves, oven, CD players, fan, electric iron, etc. So these are the electronic waste which we are generally creating from our home. And also take example hospitals, like personal computer, monitor, ECG devices, microscopes, incubator, etc. So these are the large numbers of electronic waste are generating in also hospitals. I'm taking example of government sector, like personal computer, CPUs, fax machines, Xerox machines, scanner, fan, tubelight, air conditioning, etc. So there are also large number of electronics waste are producing. Then I'm taking example of like private sector, restaurant, industry, shops, and other malls. And other examples, they are also producing large number of electronic waste, like personal computers, boiler, mixer, signal generator, incubator, many other source of electronic waste. So these are the major source of electronic which we are producing every day in our daily life. So we need to more focus about that. So then e-waste is considered the fastest growing waste stream in the world, and in 2018 an estimated 15 million of tons of e-waste was reported, thus the name of tsunami of e-waste given by UN. And in 2019 an enormous volume of e-waste, that is 53.6 metric ton with 7.3 per capita average was generated globally. And out of 53.6 metric ton of that e-waste, only just 9.3% were recycled or documented entire the world. So if taking a report of UN, in every year 5.6 crores ton electronic waste was generated in only 2019. Then if talking about the country wise, China is on the top. China is generating around 1 crores electronic waste ton every year. Then second number the US, that has 69 lakh tons every year. Then followed by India on third. Is India generating 32 lakh electronic waste ton in per year. So then if talking about the report of the Central Pollution Control Board, how the electronic waste generated per year in India. Taking example of, let's say, 2070, India generated 7 lakh ton electronic waste. Then in 2018, India generated 7.5 lakh tons of electronic waste. In 2019, India generated 10 lakh ton electronic waste. Then in 2020, it's crossed to become to 16 lakh ton electronic waste generated by India. So we can say that yearly we are now increasing day by day electronic waste in India. So we need to also focus about the electronic waste. This is a alarming situation about the electronic waste. We need to focus on that. Then as per ICA report, India Cellular and Electronics Association, so India is generating 20.6 crores of tons electronic waste in India. So in India, 40% people believe that, and even if with us, in our houses, every fourth equipment is not in working condition. That is also we have already generated electronic waste in our house. So this is the 40% scenario in India. So we need to also focus on that. And the major problem with this, that why there is not much awareness about electronic waste, why people are not talking about the electronic waste, because they don't give any exchange offer, acha offer na milna, like juna do naya lo, like that. And also people are aware with data leak. People are much very like old phone, old mobile phone, computers. So they're little worried about the, if I will sell my old mobile phone or tablet or any other electronic gadget with having my personal data, they may be leaked, they may be hacked. So these people are worried so about the electronic waste. Then the third one is the people don't know about the exact process and method about recycling of the electronic waste, why it is important to do the recycling of electronic waste. So these are the major reason in India so related to electronic waste. So if I'm talking about the typical material fraction on e-waste composition, weight percentage wise, so it contain iron and steel contain 47.9 percentage of that iron and steel. Then non-flammable retardative plastics 15.3 percentage, copper is 7 percentage, glass, then flammable retardative plastic, aluminum, printed circuit board, PCB 3.1 percent, other 4.6 percentage, wood, plywood, concrete, ceramics, other material, non-ferrous, rubbers, they are in the 0.9 percentage. This is the material fraction of the electronic waste found in generally on electronic waste. Then if I'm talking about statewide e-waste generation in India, ton per year, so Maharashtra is on top 19.8 percentage, then Tamil Nadu, Andhra Pradesh, Uttar Pradesh, West Bengal, Delhi, Karnataka, Gujarat, Madhya Pradesh 7.6 percentage statewide electric or e-waste material generation in India. Then what are the major challenges of e-waste? Globally traded due to the 60% only recyclable, presence of toxic and valuable metals, high cost for repair and comparatively low cost electronic items. So recycling very expensive, less space in landfill, improper method of dismantling electronics item by unskilled workers. If you see the way the people are doing the people are dismantling the electronic waste, so they don't know how to do the proper way to electronic waste, because they don't know about the which part is carcinogenic, which part is non-carcinogenic, which gas will it will emit. So they are doing unskillfully, so that is very very dangerous for our health. Then lack of proper rule and regulation about the electronic waste, how we can recycle the use electronic waste. So then again, now we have collected all components together. Now we have to design our lamp in certain features, like you require any some box, some equipment required to assemble all components. So instead of taking any other things, now we are going to take this mobile phone box, because it's again generated by waste material. Because when we buy a new mobile phone from the market, we are using that mobile phone and we are throwing the this mobile phone box in the dustbin. Till the warranty we are keeping with us, but after that we are just throwing in the dustbin. So instead of throwing in the dustbin, we can now use these mobile phone boxes to design this lamp, because it's in good condition, very beautiful looking also, and it is we can easily easy to handle it. So now I can design this lamp in this mobile phone boxes, any mobile phone boxes. And also this is not limited to only mobile phone boxes. If you have any plastic boxes, you can design on that. If you have any wooden boxes, you can design it, no issue. So this is the typical circuit diagram of this lamp. So here I have connected here 5 LEDs of that 8 mm. So you can connect any 4 mm, 2 mm, any LED you can connect it. So I have connected in parallel. So then I connected with the battery. This is discarded cell phone battery of 3.7 volt. If you are willing to connect tablet battery, you can connect tablet battery. If you are willing to connect laptop battery, you can connect laptop battery. So this is that black one is diode, which connected in forward bias. Then I connected one resistant, and this is the one LED connected. So when you put the solar panel over here or charging socket, mobile phone charger over here, so it will start blinking, that it will show that your current is passing through the battery and your battery is charged. So in this way you can design this lamp without any problem. So now I have designed this lamp in one mobile phone box. Here we can see that this is the charging socket. This is the power LED. When you put charger over here, it will start glowing. That is switch. We can use on off switch. So this is the top view of that LED. So I've connected this 8 LED on the top of, connected with the wire on mobile phone boxes. So this is interior view of that that mobile phones mobile box, and with that lamp design. So here we can see there is no any additional components are connected, just one mobile phone battery and one diode and resistor. So based on this, we can design this lamp, and it will glow up to 6 or 5 watt of light LED, just using waste material. So similarly, I have designed also in various mobile phone boxes by using different LEDs and distributed in different part of the Maharashtra where power supply is not there, and where you require to these lamps at night time. So we can do also this by using this. Just it is electronic waste. For someone it is very useful. Just charging only to 30 to 40 minutes. And similarly, I have also demonstrated in various school and colleges how to make this solar base lamp from the electronic base in different boxes, like plastic boxes and different box of conducted, how to make this lamp from the electronic waste. Then I have also given talk on in international schools related to electronic waste, how we can recycle, reuse electronic waste and make awareness. Not limited to only Indian participants, I have also deliver workshop and talks for international participants like Sweden and different parts of in India, like Tamil Nadu, Kerala, Leh Ladakh, and other parts of India. I have just demonstrated how we can recycle, reuse this electronic waste instead of throwing in the dustbin. So summary of this lamp is that it is very simple to construct it, do not require any specific charger. So you can use whatever charger in your home, you can charge it. Once charged for 30 to 40 minutes, it can run up to 3 to 4 hours, and also depend on battery capacity. If you are using like 4000 3000 mAh battery, it will run up to 8 to 10 hours. If you are using tablet battery, once you charge it 30 to 40 minutes, it will run up to, let's say, 24 hours or 18 hours. And if you are using laptop battery, it will run up to more than 24 hours continuously. You can use it. So then total cost will be around 100 rupees. This is not cost of the dead lamp. This is cost of the only solar panel, because if you are able to collect solar panel from the electronic waste, then it is also good. But if you want to buy, you can buy between the range of 80 to 100 rupees solar panels. But lifetime is more than 20 years. Once you purchase it, you can use till 20 years. Then one lamp consists of around 5 watt LED lights. So depending on the how much or which battery you are applying, so you can increase the number of LED. If you are using like tablet battery or laptop battery, instead of 5 LED, you can connect 10 LED. So depend on the battery performance, you can increase or decrease the number of LED or number of power of your lamp. So then now third one is that solar based smart alarm. So I will go a little bit about solar. Why I am focusing a little bit on solar. So if talking solar is the renewable energy. So there are various renewable energies are there, like hydroelectric power, wave energy, tidal energy, solar energy, biomass energy, geothermal energy, wind energy. So among these renewable energy, why solar energy are much better than? So this is the comparison table of different type of energy, their advantage and disadvantage. So among the solar energy on top, it is produced by sunlight, infinite resource of environmental friendly, a little bit expensive and last space required. So this is about the where you have solar power plants. So it is compatible. You can use a small module also. Like wind energy, but wind energy you can't do like compatible, like small solar module you can't like small module of wind energy. You required more landfills and noise pollution required. So similarly, there are advantage of various source of energy. So now my focus is on solar energy. So why solar energy? Because it's portable. You can buy different shape and sizes depend on your application. It's low cost, different shape and sizes. Again, depend on your application. You can buy small module, big module, large module, depend on your application. And also nowadays, solar cell mats are there. You can directly put on the top of your houses. You can generate electricity, also sell electricity. You can stick on your wall of your houses. You can generate electricity. So now a lot of advancement are coming in the solar cells, so that can be used. So now Also, solar energy has several advantages for other renewable energy sources, like it's clean, 100% renewable sources energy that doesn't release harmful emission or contribute to the greenhouses. Is efficient, low maintenance, low environmental impact, abundant, energy dependent, reduce energy, energy bill or electricity bill, increase property value, improve the public health. So this is the most common advantage of solar energy as compared to other renewable energy. So now, what is solar cell and solar panel? People are mostly confused between solar cell and solar panel. So this is the one number. This is called solar cell. When we have the one cell of 0.5 voltage, that becomes solar cell. Then again, to increase the voltage of that your panels, we are adding in series or parallel to increase the voltage or current or power of the solar cells. So we are just adding series in parallel. Then it becomes solar panels. After then again various solar panel combined together, then become the solar array. So in this way, depend on the application, we can use that solar panel. If you are having smaller application, we can use solar cell. If you have little big application, then you can use a solar panel. Then if you are using solar power plant, then you can use solar array, or like solar pump, you can use that solar array. So this is the most common difference between solar cell and solar panels. Then types of solar panels. So if you look at discussing about the first, that is monocrystalline solar cell. It will a little bit expensive, monocrystalline solar cell, but advantage is the higher efficiency as compared to other solar cell. Then the lifetime is more than 25 to 40 years. And if you want to identify it, it's come under the black color. So by looking just color of the solar cell, you can identify it, whether my solar cell is or solar panel is monocrystalline or polycrystalline. Then second number is that is polycrystalline, that is moderately less price, but again we have to compromise with efficiency. Then having the lifetime is between 25 to 35 years, and its appearance mostly in blue colors. Then third one is thin film based solar cell. It is less expensive, low efficiency, and lifetime is 10 to 20 years, and it's come under different color varieties. Then this is the comparison table of different types of solar cell, their cost per meter square, efficiency, lifespan, whether this technology commercially available or not. So here we can see that about the different types of solar cell. So I don't have to discuss the detail about that. And as I said, that is compatible. You can take one place to another place. Depend if you are wishing, you can take solar panel from one to place. You can install solar panel any place, anywhere, but only subjected to light must be produced. Light must be there, and also you can install on the roof of your houses. You can stop on the buses, railway station, on the top of the make smart bus station, railway station, and others that can be used solar energy. Then, so the major problem with there is a conflict between that wild animal and farmer. Like these wild animals, they are just damaging the crop of the animals. So like they are just taking seeds and destroying the crops which are ready, and like wild animal like elephants and other wild animal like nilgais, they are damaging the crops. That is very alarming for us. So damage to agriculture crop caused by wildlife has doubled. If you're taking statistical news from the Static Sweden in of 2021, the damage of caused by wildlife has doubled since latest survey in 2014. The total of 165,000 ton of grain were destroyed by wildlife in 2020, as compared to with 88,000 tons in 2017. A research conducted by Ministry of Agriculture has revealed that wild animal destroyed 144,989 metric ton of 28 food crops variety, including paddy, in the first half of 2022, causing the loss of 30,215 millions to the country. This report states that the value of food crops production amount is 30,215 millions, especially when estimated based on the prices obtained from the recognized sources. So this is the major problem with wild animal with the farmer. So now what is the solution with that? So either we have to sit on the farm and we have to observe that our crop we have to prevent from the wild animal. Sometimes it is very risky, or we have to catch every time these wild animals. That is also not feasible. Then we can kill also this animal. That is also not feasible. Or we can apply the electric current around our field, that is also not possible. Sometimes it's dangerous for us and dangerous for our wild animals, that we have to maintain our ecosystem. So then what is the solution for these problems? So now I come with one smart solution, that smart solar based smart alarm. So I have installed this one module in Angwali village of Devrug, Ratnagiri district of Maharashtra. I with the local of that village, and with an association with Sustijan Mumbai NGO, then I have installed this lamp in that in the field. So this smart alarm having the different voices which are installed in that system. You just press one button, it will start ringing that voices, and also the physical bells. Just click one button and start ringing the bell. Instead of going again and again in field, you can just clicking one button, you can just run away the birds and whatever the animals are there. And also this smart alarm having the light facility also. At the night time, it automatically switch on the light. It is light dependent switch is there, so you don't have to go and switch on the light. You can monitor by switching on light. And there are a number of facility available in the system which still have to modify it. So now summary of this project is that this is solar power with long life durability. It remote control within the range of 100 meter, and depend on the application of your houses, you can be extendable to depend on how much distance you are staying with your field, with your crop. And this consists of amount of automatic switching light based on sunlight. It is voices, mechanical bells, and with control RPM and charging points are various numbers of facility available in this smart alarm. So now this is the end of my presentation. So now I would like to express my heartfelt gratitude to Dr. Praveen Walke of NCNUM for invaluable guidance and unwavering support and encouragement throughout my research journey, and also Sustijan of Mumbai for their help and support in installing these smart alarms and other projects. Thank their consistent support, motivation, and encouragement of during this journey. So this is summary. We have discussed about the supercapacitor, then electronic waste, lamp from the waste material, that electronic waste, then the smart alarm of the which is based on solar panel. So this is today our method. Thank you so much.
I'd like to ask one question regarding this storage in mega capacity. See, now what we are doing, all the solar panel systems are converted into hydrogen manufacturing systems for a simple purpose of storage, right? Storage and using it in the required time. So, in your research, have you done anything potential to become a storage capacity for megawatts of power, right? Because now you see we use the solar for converting to hydrogen or ammonia, then again we transfer it, again we take it to power back. Instead, the storage in the cells, particularly using nanoparticles, may be also a good solution. I need your input, sir.
So actually, we can do it, but my area of expertise that electrochemical battery and supercapacitor. So mostly we explored anode and cathode material for zinc ion battery and supercapacitor. A lot of people are doing as a catalyst, nanomaterial as a catalyst for like hydrogen reaction of OER, like electrolyzer. So we can split the water in form of hydrogen oxygen. Later you can use as fuel cell.
Okay. In your product, can it be expanded to industrial scale, sir? Is that any research pending there?
Yeah, yes. I have designed one or two more model that can be utilized, but a lot of research yet we have to do on that. Okay. That is based on the based on the air purifier, where I have prepared like nanofiber that can be trap toxic gases or carcinogenic material in that nanofiber, then can be used for air filtration. So I have designed that which lab working on that, because on that there is a problem related to cleaning of that filter, like people are using like HEPA filter and other filter like activated charcoal. That the major problem is that on that. So I'm working on self cleaning that fiber. If I will get succeed on self cleaning nanofiber, then I can use that air purifier as that nanomaterial.
Okay.
Yeah.
Sir, Anil Joshi ji, sir, you can ask the question.
Thank you, Nishad. I think an excellent lecture, and particularly the top. Can you hear me?
Yes, sir. You are audible, sir.
So basically, the lecture covered very well the e-waste part. I think it is a very burning problem for the nation,
Exactly.
which has been much ignored, in my opinion, till now by policymakers.
Yes.
But what I want to understand, and I think Mr. Abhimanyu and people like Mr. Abhimanyu can contribute to the idea that you have just given, that how to salvage individual parts of all these wastes, like more like a cottage industry, and to make
Yes.
sure that it becomes an industry. Like
Yes.
probably a model that I am thinking is just listening to you is probably to adopt villages who
Yes.
do these type of jobs which are sort of manual with some sort of training, and
Yes. Exactly.
maybe as a business idea, because we know that things can be salvaged to some percentage. That is very correct. You know, the entire thing, maybe 10%, 15%, 20% of the product can be salvaged. But
Yes.
how to move it to a business idea? How to make it happen? That is the challenge. I think people like Abhimanyu or entrepreneurs may probably devise a thing that we adopt some villages who do this, catch this waste from the e-waste aggregators and then take it there. But probably there's nothing that the government is particularly probably doing, although there are laws to this effect, that what is called the producer responsibility. But I
Yes.
don't
Yes.
see a producer in China taking responsibility in India, because all the e-waste is coming from China only. You showed China 1 crore something, but I think hundreds of crores is being piled up in other countries like India.
Exactly.
So I don't know how the government policy of enforcing e-waste through a producer responsibility, when we do primarily with dealers here, how the dealer will actually salvage the product as a waste. So that is the policy part. I know you are a scientist, and so you will not be concerned on that. But as a citizen, I think this is a point of worry, that policies that are laid down, and there is heavy penalties on that, 1 lakh for one violation, and the
Yes.
cancellation of the license, and a lot of things are well laid out. But I've never heard a Dell or a Intel or anyone who's making computers or mobiles being penalized anywhere in the media last 10 years. And this policy
Exactly.
is in place for 10 years now. So
Yes.
this extended produce, I think as a group, we need to see probably, Abhimanyuji, to make sure that we have some villages, small cottage industries or something like that, who learn the tricks of the trade, salvage whatever part is there. But again, it becomes very tricky because of cyber security rights, as you were saying. What is left in the computer, what are the data left, how
Exactly.
to dismantle the hard disk, who will pick up these parts. Probably it is going at more of a business model that we need to see. Because science is one part, prototype doing is one part. But I am very pleased with this idea of your electronic alarms for wildlife and other things, because this is a particular challenge for solar. Solar
Yes.
is particularly challenged in the where it is installed in the water reservoirs. Okay,
Yes.
because that is a place where most of the birds sit. Because
Yes.
in a reservoir, the best place to sit is the solar panel. So there's a lot of damage to solar panels for that. So what we have done in the country is put electronic buzzers. But probably the idea of connecting to a solar itself, there itself, and creating a continuous alarm would be a good idea. So I think we
Yes.
have good ideas, and I think we need to make it into something which the country can use. So
Yes.
probably Abhimanyu and you are well positioned to sort of build on the ideas you have. Thank you.
Yes. Thank you, sir,
Thanks, sir.
for your feedback and some suggestions. That is quite interesting. So that's why, sir, whenever I conduct workshops, seminars, maybe related to my hardcore research like nanoscience and technology for battery application, I always include this electron waste also and whatever the current challenges. So that's why people may get awareness like such today public talk. So now some people are
Very good idea.
very useful. So that's why I always modify my presentation according to that. Let's have make awareness the people's. Like you people are already industrialists, you know very well about these things. But a lot of people we don't know about this.
That's it.
Thank you, sir.
Thank you.